Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. 3-methyl-2-butanone has the structure CH3-Co-CH, CH3-2A ketone with molecular formula C5H10O. Option A, CH3 oxidation of 2-methyl-2-butanol. 2-methyl-2-butanol is CH3-C or CH2CH3, a tertiary alcohol. Tertiary alcohols cannot be oxidized by CH3. They have no H on the carbon-bearing O. So option A is false. Option B, reaction of 3-methyl-2-butanone with NaBH4. NaBH4 reduces ketones to secondary alcohols. Reducing CH3-Co-CH, CH3, to gives CH3-CH or CH3-2, which is 3-methyl-2-butanol, a secondary alcohol, or on C2 which bears both C1 and C3 substituents. So option B is true. Option C, acidic Hg2 plus catalyzed hydration of 3-methyl-1-butene. 3-methyl-1-butene is HCCCH, CH3-2. Markovnikov addition of water to the terminal alkyne with Hg2 plus H plus places O on C2 more substituted carbon, giving the enol CH2 is equal to C or CH, CH3, 2, which tautomerases to the ketone CH3-Co-CH, CH3, 2, i.e. 3-methyl-2-butanone. So option C is true. Option D, silver mirror test with Ag, NH3, 2+. This is Tollens reagent, which is only positive for aldehydes and some alpha-hydroxy ketones, not for simple ketones. 3-methyl-2-butanone is a ketone with no aldehyde functionality, so it does not give a silver mirror. Option D is false. Option E is 3-methyl-2-butanone, an isomer of 4-pentan-1-ol. 3-methyl-2-butanone, C5H10O. 4-pentan-1-ol, CH2 is equal to CH, CH2, CH2O, molecular formula C5H10O. Both have the same molecular formula C5H10O, so they are constitutional isomers. Option E is true. Therefore, the correct answer is B, C, E. The correct answer is shown on screen.